Any questions so far? Do you understand? Everyone? By looking at the formulae, you basically can explain what happened with the electromagnetic inductions. In the mündliche Prüfung, certainly, I will ask you the concept as well, right? Not only that you can do the calculations. Calculations cannot be asked too much because we don't have so much time. The concept will also be asked, and sometimes more importantly. Alright, now, do you still remember the examples I gave you? Yeah, on what page is it, brother, sister? There are 4 examples that I'm going to discuss, or three I guess, and one of them has been explained, which is this one. Am I with you, this one? Do you still remember examples? A moving conductor in a magnetic field, and then I have the formulae V and V. Where's my linear? Usually it's here. No, there, right? A moving conductor in a magnetic field, and what is then the last result we get? If you have only a single conductor moving in a magnetic field, has a changing of area in terms of area in the magnetic field, you create BLV. Induced EMF, BLV. And then you can use this in the classroom. You don't have to derive it again from the very beginning. And then we go to here. The one that we also practice in the exercise. If you have a rectangular coil moving, who watched the video in the YouTube? Not the bad part that you guys created, but the good part, the good physics we created in the, because I don't have time. I already uploaded. Now it's become viral everywhere. The one that Miss Kyra has started, on you see. You are the problem, So, do you remember that? We had an exercise, yes? Which is correlated to these questions, right? Remember? Okay, so tell me, now your turn. What did you learn from this second example? You have rectangular coil, understand? And then all started with this one, am I right? It all started with this formula, correct? You have EMF created the number of coil, sometimes 500, just like the question. Is the question with 500 coil winding? Oh, 15 turns only. Do you see that? Do you see that, people?
Yeah.
It is with 15 turns, so the N is here. And then we have BDA plus ADB. Which one has been cancelled? Which one has been taken away? Which is not relevant to our problem. Do we have change of magnetic flux density? Or do we have change of area? Yes. So is it gone, everyone? Yes, remember that? So we have EMF is basically M, B, and B, A. Correct. MBA. Or to be more exact, actually, MBA accent. Differential of A. Changing of A in time. dA over dt is just differential of A. MBA. But A accent. Correct, yes? Or I don't want to put you into a hard pressure with math, so I'm just writing MBA. BA. Correct? Remember that? And then it helps you with further calculations, MBA, dt, and then you come up with this formula, which is the formula is this one, right? When the coil is completely in the field, then the A is, when it is completely in the field, the A is, for instance, it's starting from t equals to 0 and t when the coil completely in field. Then you have EMF is MBA A total, correct? The whole triangular coil is now in the field, in the magnetic field, minus when the coil is not yet there, correct? When the coil is not yet in the field, meaning the area of the coil in the field, in respect to the field, nothing at all. And that's the change of the area, correct? Divided by the time needed for the coil to be completely coming into the field. Are you with me? Yes. The change of the area on time, in time, is exactly what is needed here, not the area itself. And be careful with the questions, because in our exercise, it's just between this time frame. And then it expands again with another questions. And that's exactly what we are going to do now. Repeat, and understand again, and do further. Number one, yes. So far so good. Is this review helpful enough for you? Because we missed the class last week. Yeah. And Naomi is still thinking, do I take physics? Do I take biology? Do I take physics? So I try to make the physics as hard as possible today. That's my mission. We're just kidding. Sister, can you read it for us, Sister Naomi?
Oh, okay. One.
Yes, we repeat and then we do it.
Uniform magnetic field of flux density 72
No, 72 milli Tesla. 72 milli Tesla, 10 to the power of negative 3 Tesla is confined
to a region with 60 millimeters fashion in figure 11.
And by reading that, we know immediately that the magnetic flux density changing or not changing?
Not changing.
Not changing. Is it a steady magnetic field?
Yeah.
Yes. How big?
Huh?
How big? How strong? 72, 10 to minus 3 Tesla. Correct? And then rectangular coil.
A rectangular coil of less 50 millimeters and width of 20 millimeters has 15 turns. The
Yes. So what is this 20 times 50? The area of the coil. As the area of the coil, as the coil is still outside the magnetic field, it's not important at all for us, correct? When it comes to electromagnetic inductions. But then, as this area, if this is the magnetic field, but the area changing here, if this is the whole magnetic field now inside this green board, the area that has been changing here is the one that is important to us. Even if you move it faster, it's even more important to us. Because dA over dt, the change in time, dt means change time. Understand? The faster, the better. Okay? Now, then, can you read again? The coil is moved into?
The coil is moved into the magnetic field at a speed of 10 millimeters per second to the power of -1 with its power edge parallel to the edge of the magnetic field.
Yes. Can somebody explain again? Question A. The one that we have solved until AI, AII, and AIII. AI, and triple I. We have done the whole I, correct? And the whole A. The whole A. AI, artificial intelligence. AII, artificial intelligence, even in Uganda, and AIII. Yeah, thank you, Kyra. Thank you for your readiness to explain again for us.
Explain
Yeah.
one.
The A, explain again for us. Explain again. Thank you, Kyra. You're so nice. You're good. Thank you. Danke, dass du hast dich angemeldet.
Dass du dich freiwillig gemeldet hast.
Ja, hat sie gemeldet, oder?
Ja.
Nicht angemeldet, bereit gemeldet, ja?
Ja, freiwillig gemeldet.
Freiwillig gemeldet, genau.
We just do AI.
Yes, AI, that's right. Alright, you just explain again, but now I'm going to check whether you understand or not understand. Whether you can explain it once more or not. So that I know you guys understand or not understand.
If it's inside,
What is the question first? Can you tell what the question is first?
the flux engaged through the coil when it is completely
Yes. The flux linkage, do you remember the flux linkage is NBA, right? NBA. Flux linkage is just NBA, not NBA over time, but NBA. Yes, now it's completely there. Correct.
And then so the flux engaged,
Mm-hmm. Flux linkage is basically just
the N times
yes. Can you write flux linkage equals to? Remember that word, yeah, everyone? Linkage, the link, flux linkage, NB. No, you don't have to. Can you just give the last answer? N we know, B we know, A we know, right? The whole area of rectangular is there. Actually, you don't have to write any more, sisters, brothers, because you have already answered that with this. Yes, it's already there. It's just a little view. What is it? BB. Yeah, Weber. Alright, and then that's an I. Can you write I? AI, and now AII. What is the questions?
the time taken from flux linkage to increase from 0 to its maximum.
Yeah, from 0 to hero. So, what is the time? Brother Vincent has helped us to calculate the time, right? Let's smart. Last time, remember?
The width divided by speed.
The weight divided by. Can you write the formula? The weight of who? Yes. Yes. The weight you know, which is 20 millimeter, correct, brother? Sister? And then? 2 seconds. Alright. And then? I.
The induced EMF in the coil as the induced
Yes.
is the equal.
And D. As it enters, and it's about to enter, correct? As it's just about to enter, meaning it doesn't have to be completely now fully inside the field, the whole total rectangular area, but now it's about to enter gradually. And B, dA, not only A, sister, dA over dt. dA over dt.
Basically just NBA divided by.
Be careful, this time not so easy like that. Be careful. This is just about to enter, meaning the whole process of, can you shift it? The whole process of as it enters. The whole process here, the whole process here. Meaning you have to know that the length is constant with respect to the magnetic field, meaning you have epsilon and B, and this is the length, and this is the weight, divided by D. So dW divided by dt, which is N D L width divided by time, length, this 20 millimeter divided by time. Distance by time, CA, MBLP. Whoa, that's in the book actually, correct? It's basically in the book, correct? Which is here, am I right? MBLP. That's basically the answer for our IIIA questions. Usually we want to have a break yet. Or are we done?
We're done.
Oh.
12-hour break. 20-hour.
You're still so happy. You don't have physics with me. Have I succeeded making this physics lesson today even harder? No. Easier, yeah? Oh, so my mission is not good, yeah?
It's me.
Aku hanya
It's
pilih
so
buat
not me.
semakin takut dengan physics.